Good morning, Phoenix class, and welcome to Monday's maths lesson. So I can investigate angles in a triangle. So our success criteria, what you're going to be able to do by the end of this lesson, is I can investigate angles and draw conclusions. I know that the interior angles of a triangle total 180 degrees, and I know that the sum of the angles on a straight line is 180 degrees. There are some things that we need to revisit first that you'll need to remember to help you with today's lesson. So here are all different types of angles. Which ones do you remember? You've got an acute angle, so that is any angle that is less than 90 degrees. You have a right angle, so that angle is exactly 90 degrees. And quite often it is shown with a square in the corner of the angle rather than a curve. Then there's an obtuse angle. So this is when the angle is more than 90 degrees, but less than 180. Straight line, now that is exactly 180 degrees. And as you can see, it's like two 90-degree angles together. Now, for an angle that is more than 90 degrees, more than 180 degrees rather, it is called a reflex angle. And then if we go all the way round, it's a full rotation, which is exactly 360 degrees. So let's move on to our first question. Now, this is asking you to attempt the challenge that is on the board. So the challenge of the week, draw a triangle with two obtuse angles. Well, first of all, how do we draw a triangle accurately? Now, if we were going to do it really properly, we would use a protractor. However, we can make good estimates of our angles without needing a protractor. What you will need is a ruler or a straight edge to draw up against. You're going to need to estimate your angles unless you do have a protractor at home. So how many sides does a triangle have? Well, it's got three sides, hasn't it? Three sides, three angles. But we need to think, what is an obtuse angle? Well, like we looked at earlier, an obtuse angle is an angle that is greater than 90 degrees, more than 90 degrees, but less than 180. The challenge is drawing two of those and then turning it into a triangle. Is that possible? Can you do that? I want you to have a little play, an investigation, and work out if that is possible. Let me know. So what do you think of Kate's solution here? Has she solved the challenge? Could Kate's solution actually work? How can you tell this without measuring? Look at those angles. What do you notice about them? The one at the top right, we've got as 90 degrees. We can tell that because she's put a little square in there. That looks like 90 degrees, doesn't it? But what about those other angles? She said one of them is 140 and the other is 130. Can you remember what we've just done at the beginning of the lesson? There we go. An acute angle is less than 90 degrees. So can her top left angle be 140? Well, 140 is more than 90 degrees. Does that angle look like it's more than 90 degrees? What about the bottom angle? She's labelled that as 130. Could that be right? Remember, an acute angle is less than 90 degrees. What do you think? Does Kate's solution work? Now here, Max has drawn his triangle and then he's torn it into pieces. He's labelled all the angles, hasn't he? A, B and C. And he's torn it into three parts, so each part has one of those angles. And then he's lined them up on a point, so they all are together. What has he made along here? Looks like he's made a straight line, doesn't it? Well, what I want you to do is I want you to draw some triangles of your own, different sizes, different types, maybe an isosceles, maybe a scalene. When you do this and label them all A, B, C, put them together, do they always make a straight line across the bottom? If they do, maybe we can turn that into a generalization. We know a straight line is 180 degrees. So could we say that the interior angles of a triangle add up to 180 degrees because all of them line up to make a straight line? Now, what do you need to do in this question? I want to know which one of these triangles has been measured correctly. You do not need to measure the angles. The generalization we just made, which you're going to prove to me on the previous slide, is interior angles of a triangle add up to 180 degrees. Well, if that's true, let's have a look. On A, 60 plus 60, well, that's 120, plus another 60 is 180. So has that been measured correctly? Yes, it has. Let's have a look at B. Remember, the square there means 90 degrees. So we've got 90 plus 50 plus 60. What do they add up to? Is it 180? And then on C, we've got three angles. We've got 60, we've got 100, and we've got 40. What do all those angles add up to? Now this one, what is the missing angle? Explain how you know. And again, what do all our angles in a triangle have to add up to? If they all have to add up to 180, work out what 60 add 30 adds up to, and then take it away from 180, and that will leave you what our missing angle is. The answer's there to check as well. Now you're going to go into your practice book. So, number one, which of these angles has been measured incorrectly? So incorrectly means wrong. So you know now that all the angles have to add up to 180. So just work out for each one if that is the case. Question 2, what's the missing angle? Well, if all the angles in a triangle add up to 180, we can work out what 110 add 40 is, and then find the difference between that number and 180 by using a takeaway, and that will tell us our missing angle. Now, question 3, that's doing what you did at the beginning of the lesson, tearing the triangles up and then putting them on a straight line. You can do it in practice, draw some of the triangles out and have a go and see which one you think. You've got to match them to the straight line. Then the last question, which statements are always true, which are sometimes true, and which are never true? You might have to draw some out to see what you think. You've got some challenges there. If you're thinking, oh yes, I'm really confident, I definitely want you to have a go at doing the challenges. If you're thinking, oh, I'm still not quite sure yet, well, have another go. Here are some more triangles for you to find the missing angles. Now it comes to your reflection. What is the sum of the angles in the triangle? How do you know? How can you prove it? Well, remember how we proved it before by putting the triangles angles on a straight line? That might help you. Then right at the very end of the PowerPoint, you've got all the answers. Have fun